Hello everyone. Welcome back to our session on Python programming. We have covered up certain basic concepts till now in Python. Last time we looked at an iterator protocol. That was something advanced. Today, the next topic that we plan to focus on is to understand a concept of generators. Now, to understand this concept of generators, we also have to understand one more concept, and that is what I'll begin with today. There is a statement called as yield that has been introduced in Python. Now, what does yield do? Now, before we come to this concept of yield, we need to recollect what did return statement do. If you remember the return statement, it could return a value. It could return a control to the calling routine. So if a function A was called from function B, so when I say return from B, it transfers the control back to function A. It is not just about the function control which is being transferred. We can also transfer value or return value to the calling routine. So what is this yield and what does it provide you more than the return statement? That's precisely what we'll try and understand. So let's jump on to exploring what is this yield statement in Python. Here. So what we plan to start off today is this concept of yield statement. So let's explore what this yield statement is. A second. So when we talk about this yield statement, which is available in Python, it returns a value, each value to the caller, and then returns to the caller when all values to returns have been exhausted. So is it like a return statement or is it anyway different? Like a return statement returns a value. Yield also returns a value. But then once return has returned the value, the function has been removed from the memory. The stack frame, we have been talking about the activation record that was created when a function is called, that entire record is destroyed. Since we return from a function, that function goes off from the memory. When you give a call, again a new activation record gets created in the memory onto the stack. The frame itself is destroyed when we return from a function. That does not happen when we yield. So there could be a function that we design that may not stop its execution by saying return. Rather, it is about to return or generate more than one values, and it returns a value. That means the control is temporarily passed outside that function. So next time when the caller calls that particular function, you continue from the place from where you had already returned. So you have more than one places from the program from where you can return a value. It's like you have to move from Pune to say Ahmedabad, and you have to report on the way where have you reached. So it's not like we'll only when we reach Ahmedabad I'll report. I reach Lonavala, I'll report. Okay, I've reached Lonavala. Then next time somebody asks, where are you? You may say, I am in Khandala. Next time you may say, I'm in Thane. Next time I'm in Mumbai, and then Surat, and then Vadodara, and then. So every time what is happening is, every time you reach some milestone, you're going to return the control back to the caller, reporting to the caller, oh, this is what I have done till now. So you could design a function. It's a very powerful construct. Very lately, we see this particular concept now being introduced in other languages. For me, it was C++. No, it was Python the first time when I saw such kind of concept. Otherwise, once we return from function, it's forever return. That function is destroyed. Yield gives you an opportunity to return more than one values from a function over a period of time. It's like it will keep on generating values. It will keep on returning you values. And when it is exhausted with all the values that it is supposed to return, then it will stop. The yield paradigm becomes important in the context of generators. So we're going to learn this concept of generators, which are powerful tools for creating iterators. Remember last time we used iterator, which is the method that we looked into iterator. So that if I wanted to have the next element, which is the method that we used to call?
For.
Yes.
Next.
Next is the method that we called. So next method gave you the next value. But now if my collection had 5 elements, 5 times I could call next. And each time it went on returning one value to us. When we had exhausted with all the values, then it returned us, it raised an error. Does anyone remember the error that it returned? It raised? When the iterator exhausted returning all the values, Anybody remembers the error that it gave? It was stop iteration error that was raised when everything has been written. Generators are like regular function. When instead of returning a final value in the end, they use the yield statement return data during execution. So as the function is running, it will keep on returning you more than one values. And once it has finished returning all the values, then it will stop. So generators are special kind of functions. Regular functions can return only a single value. Generators are special kind of functions which can return series of values to you, one after another. And once it has finished or exhausted returning all the values, then that function will say stop iteration, or it can return from that particular function forever. The values are extracted from the iterator one at a time by calling next method. Oh, exactly what we did. So we will now create something like an iterator. And at each of these calls, the yield expressions value is returned. So yield will be followed with some value optionally. So return that value. If you don't give yield something, it will return none. But you can give a value that the yield is supposed to return to the caller. So every time yield statement is encountered, it will return a value to the caller. And once it has finished with all the calls, it will raise stop iteration error. Yield statement returns a function, turns the function into a generator. So if I have a regular function, I can convert the regular function into a generator. Generator, as the name says, generates a series of values. Yield statement sends the result back to the object back to the caller, but remembers where it left off. Means what? Suppose it's a 10-line code. On the 4th line, you say yield. And when you come back to your caller, it will remember, from which line did you return? So next time when you go back to the function, it will continue from the place where you had last left off. So let's understand this yield working before I go ahead with more detailed discussion of generators. For that, I'll jump ahead with an example to help you understand that. Now, first understand the behavior. Now, once you understand the behavior, then it will make sense for us to explore generators in more detail. So the basic working is what you need to understand first. Have a look at this particular function. There is a function. Have a look at this function. A very simple function called as foo. Now, this is to understand the difference between a regular function and a generator function or a generator. So we are trying to understand how to create a new iterators. A user-defined iterator is what you would like to create. So let's see how we can do that. I have this particular function foo. And what does foo do? Whenever I give a call to this function foo, it will come inside. It will execute all the statements and then it will return. The return will transfer the control back to the place from where the call has been given. Second time when I call foo, it will again start executing right from the beginning. Let's check that thing out. Suppose we are at line number 41. We start debugging this particular code. We are at 41. We give a call to this particular function foo. See what happens. When I give a call, I come to this function foo. Look where the control has gone, to line number 9 at the beginning of that particular function. So we start executing the function right at the beginning. We print cricket, then kabaddi, lingorcha, hockey, and then I say return. The moment I say return, control is transferred back to the place from where the call has been given. It goes back. Not just that, the frame must have been destroyed. Remember that visualizer that I had shown you? Every time we give a call, a frame is loaded. Every time we return, the frame gets destroyed and so on. Now note, we are now at line number 42. I give a second call to the function. Every time we call a function, control is transferred at the beginning of the function. It will go ahead executing all the statements and then we'll return. Let's see what happens over here now. We again go to line number 9. We execute these instructions all over again. And then we say return. This return will again transfer the control back to the place from where the call has been given. Again, we give a call to this function foo third time. Even when I give a call to this function for the third time, same thing is going to happen. Watch it. We again go back at the beginning of the function. That means every time you call a function, the entire body of the function is being executed. That means a new activation record gets created, a new frame is loaded on the stack. It will start executing right from the beginning. It is not that, oh, last time I returned from line number 14, so my control will go to line number 14. No, that's not what will happen. So here we are at line number 9. We start executing. We say print cricket. We say print cricket. So cricket has been printed. Then kabaddi, then lingocha, hockey, and then we say return. And that has taken control back. Back where? Back to the place from where the call has been given. That was the third call. If I had to execute this function directly, let's execute this function directly. You'll understand it in more detail. Look at this. This first output, second output, and third output. 3 different calls. So every time we call a function, control is, and suppose if I had written return statement over here, so in that case, these statements are unnecessary. They will never be executed. Why? Because when you say return at line number 11, control will return from that line. So every time it will print only cricket, cricket, cricket. So first time I give a call, print cricket, return. Second time I give a call, print cricket, return. The point is, the execution of the program starts from line number 1. Every time we give a call to function, it will start executing that function from the first line of that function and go on to execute the instructions till the time it doesn't come across a return statement. Only when it comes across a return statement, the control is transferred back to the caller. Then what is different that we plan to achieve now? We plan to create a generator. Have a look at this particular generator now. We could also check this thing out on the visualizer to see what happens. I don't know how this visualizer visualize this. This is okay. This particular code will correctly visualize. But for generators, I doubt whether these visualizers are so accurate. But let's check it out. Here we go. Let's start visualizing the code. The function foo is there in the memory. Okay. So function is being created. This is a function object that is there. But we haven't yet called that function. Line number 9, we call the function note. A frame has been loaded. Frame has been loaded, and then it will go on to print all the values. It has printed. When we say return, control goes back. But moment the control is returned, this function, this frame will also be destroyed. What's this foo frame that gets destroyed moment you return from that particular function? So moment you give a call to a function, the frame is loaded, and moment you return from the function, the frame is destroyed. So moment I say return from here, this particular frame that we have for this function will get destroyed. Watch it. The frame has been destroyed. So moment you call a function, frame was created. Moment you return from the function, the frame has been destroyed. I give a call, second call to the function. Again, I come into the function. We print this particular values. Again, I say return. Moment I say return, the frame has been destroyed. Third time when I give a call note, third time the frame has now been loaded. It will go ahead executing the statements, all the same statements, return, and look at this. This frame will now get destroyed when we return from that function. Point that I'm trying to put across is, every time you call a function, an activation record is created on the stack. Moment you return from that function, that stack frame is now destroyed. And execution always begins from the first line inside the function. And it goes on executing till the time it doesn't come across a return statement. Now, what is different that we plan to do? We are now exploring a concept called as generator functions or generators. What are generators and how are they different? Watch the design of that particular function and try and understand the behavior. So be careful, pay attention as we go ahead. Here we have a function called as sport generator. I have a counter variable whose value is 1. I print the value of the counter. Then I say counter is equal to counter plus 1. And then I yield cricket. So here we are saying return. Here I'm saying yield. I say yield cricket, counter increments, I yield football, counter increments, I yield hockey. Likewise, I'm going to yield a lot of values. See what happens when I give a call. Last time when we called the function, what happened was the frame was loaded in the memory. Here, when we call a generator function, it's not about frame being just loaded in the memory, control being transferred. Rather, since this particular function has a statement called as yield, it returns a generator object. It does not call the function. Watch it. I'm at line number 46. It looks like as if I'm calling this function, but calling this function will not transfer the control to the line number 1 inside this function. That will not happen. This is a special function called a generator. So when we call this generator function, control will not be transferred into the body of the function. Rather, it will return us something called as generator object. Just to understand that, let me print this particular object for you here. And let's understand what this object called as sport is all about. Just for our sake of understanding, exploring. Let's debug this particular code. We are at line number 46. We give a call to this function called as stop generator. Normally what happened? Last time when we call foo, control immediately jumped to line number 9 and it went ahead executing. Watch, I'm at like this line. I call that particular function, but no control is being transferred to that function. Nothing happened. It did not call that function. Rather, the function gets executed and returns a generator object. So if I print sports, what is sports? It says it's a generator object of the type called as sport generator. So we had the generator function called as sport generator, and a generator object has now been created. Okay. So what do? I say next of sport. Like yesterday with iterator also, we had used this next. So if I say next of sport, see what happens. I'm going to trace this code now. First time we are calling this method next. That's the time you'll find control being transferred into the body of the function. See, the control has gone to the function. And it will not execute all the statements from the function. It will go ahead executing the statement till the time it doesn't come across yield statement. Watch it. Counter is 1. Counter value is printed. And now we say counter equal counter plus 2, 1, that becomes 2. And I say yield cricket. Now, moment I say yield cricket, just like return, it will return the value, but it will remember it was from line number 21. It has temporarily returned from that function. So the next call will transfer the control exactly to the same line number 21. It will not begin executing the function from the beginning. It will continue executing that function from the point from where it has returned earlier. So yield also returns the control back to the caller, but it remembers the place from where it has yielded last. So next call, the control will be transferred to the same line number 21. Watch it. We're at line number 21 now. We are saying yield. See what happens. Moment I say yield cricket. Okay, sorry. I pressed the wrong button. Let's debug the code once again. Here we are. We give a call. We print. First call we have given. We come here. Counter is printed. We say yield cricket. Now, moment I say yield cricket, see what happens. Control is transferred back to the caller main. And we are going to print the result. The result will now be cricket. Look at that. The result is cricket. So it has returned the cricket value. I give a second call. That's my second call. Moment I give a call, oh, it went to the same line from where it has yielded value last. It did not start executing the code from the beginning. It has jumped to line number 21 instead of line number 17. Now, from that line, it will continue. It prints counter. Counter is 2 now. Counter becomes 3. And I say yield football. Moment I say yield football, look, from line number 24, you will go back to your main function once again. Have you come? Just like return. But the function has not been destroyed. It remembers the line from where it has last returned. So the next call will transfer the control to the place in the function from where it has yielded the value the last time. So now if I print this, it says football, and see what happens. Line number 54, I again give a call. It won't start executing from the beginning, but it will continue from the place from where it yielded last. That's line number 24. See what happens. It goes to line number 24 again. It goes to line number 24. It now prints a counter. That's 3. Counter becomes 4. Yield hockey. Now, moment I see yield hockey, control again is transferred back to the caller. It will print hockey, whatever you would like to do. The next call to the next continues from the same line number 27 from where it has yielded last. Same thing is going to happen every time now. Watch it. Tennis. Okay. From tennis, I come to basketball. I yield. You come back. You print the value. And then next call, we'll again transfer the control back to the basketball. Same place. It'll execute the statement. And next again, I say kabaddi. And moment I say yield kabaddi, it comes back. It prints kabaddi. And I give a call once again. That's a terminal call, like last call. I give a call. And we say return no more sports. So you say return no more sport. It has printed the result saying no more sport. That was an error now. Stop iteration. Because there was nothing more that could be yielded. So we have got an error saying no more sport. Let's run this code directly to see the behavior. So it will yield all the sports 1, 2, 3, 4, 5, 6, and then at the end it will generate an error saying stop iteration because there are no more sports to be yielded. Because after yielding kabaddi, you are again giving a call to the next function and you're passing the generator object. There is nothing more to generate. So it returns the value and this becomes the error message with our stop iteration error, which has now been generated. Okay, and you cannot execute it again. Like you remember last time we talked about, you can iterate over it only once. So if I start iterating again, it will generate an error. It will generate an error. So here we go. It will generate error, stop iteration, stop it, because it has yielded all the values that it could probably return. Have you understood this particular behavior, everybody? Any questions? Ashish, Putra, Shantanu, turn your cameras on. Any questions, anybody?
Could you repeat again that yield?
Welcome again.
When does the control come into the loop, into the function, and when does it leave?
Every time you give a call, control will come into the function. But at which line in the function? It's not a function, it's a generator now. From the place from where it has yielded last. And it will go on executing the statements inside the function till the line, till the time it doesn't come across either the return statement or the yield statement. The only way to go back to your caller is by calling yield or by calling return. But think about return as a terminal statement. So once returned, everything is gone forever. Now to just cross check this, let's see how does the visualizer visualize it in a proper way. Let us not do it for these many times. Let's do it only for 3 times. Let's see how does the visualizer visualize it. I'll just copy this. I don't know visualize whether they are so advanced to even visualize this. If it is, then we should be happy. But I really doubt whether visualizers can visualize such complex concept. Let's start visualizing this code. Let's see what's happening here. So this is a generator object. The generator object has been created. It's a special kind of function. Let's see what happens when I give a call to that function. The control should not go to the function, rather it should return an object. Yeah, that's good. So a generator instance has now got created. It's a generator object. Sports is pointing to generator. This generator object can know how to get the values from this function. Look at this. Now I print sport. Oh, that was unnecessary. So it is generator object. And first call I'm giving here, line number 16, next. The moment I give a call, that's the first time the function is now being loaded in memory. Okay. But every time you return, function frame gets destroyed. So now with the call to the next function, the function frame has been loaded in memory. Watch here, the function frame has now been loaded. We go on to execute the statements from the function counter and then we yield return cricket. Now look at this, return value is cricket. So it's going to return the cricket. I'm saying yield cricket, but it's actually going to return the value cricket. Where? To the place from where the call has been given. Call was given from line number 16. So control goes to line number 16. The variable result now gets the value cricket that he has returned. So I print this. So we got cricket. I give a call, second call. But this time control will not go to line number 2. Okay. Control should go to line number 6 again. Let's see whether it does that. Now look at that. Control has gone to line number 6. And the generator object still there. It remembers our counter to value was 2. It's not, if it has started executing from line number 2, then the counter to value would have been 1. But it remembers the state of the function the last time what was there. So actually this is not destroyed. It's there in the memory. That's the reason it could remember the value of this variable called as counter. Counter value is 2 now. It has gone back to line number 6. Watch it. We print and then counter is incremented. We yield football. Now, moment I yield football, control is again transferred back to the place from where the call has been given. We print the result. That's football. I give a third call. It remembers the place from where the call was given last. It has written last, line number 9. And then here we are saying return no more sport. So it will return no more sport. And then that value is what we try and print. So that's an error because we have exhausted with all the elements which are present. So here it shows red color means it's an error that we have now come across. Okay, why the error? Because it has exhausted with all the values that it could yield. Return over here, return no more sport is now generating an error. So if the error message gets printed like what happened last time, that would give us a message saying there are no more sports here. Somewhere we had seen that. Oh, I could just run it once. Here, stop iteration, no more sports. That's an error message that it can give. So have you understood this concept now? If you are really understood, you should be happy because these are the, what do you say, the advanced features of functions that you can find in any programming language. And as I told you, many other language designers are now trying to incorporate such kind of behavior or functionality in the languages, C++, Java, all of them are trying. But then Python has it for a very long time now. So Python also has the edge over other languages because it has some feature which you cannot expect in other languages. This is one such feature which is special for Python. It can return, what do you say, intermediate values from a function. So it can return series of values from a function, not just one value. It creates a generator. As the name says, generator. A generator keeps on generating energy. Likewise, this generator will keep on generating the values over a period of time. And once it is exhausted generating the values, at that time it will raise an error saying stop iteration. So let's go and explore a bit more about generators.
Sir,
Yes, please.
sir, can we avoid writing that next statement all the time?
Yeah, that is just to make you understand the behavior. There is absolutely no need for you to call the next statement every time. You can use the generator and run a for loop. It will just run through all the elements. Okay, so that's also possible. Generators are very robust and efficient, and they should be considered every time you deal with a function that returns a sequence or creates a loop. So if you want a function that will return series of values to you, not just one value, or not just return once, it has to return over a period of time, several values, one after another. Think about generators. It allows you to declare a function that behaves like an iterator. Generators are iterators, but you can only iterate them over them once. So you can iterate to a generator only once. It's because they do not store the values in the memory, they generate values on the fly. That means whatever are the values that it has returned, they are not stored actually. It will calculate, return, and then that value is lost. So it generates the value. It will not create a list in which you store the result, then we return a list. Somewhere in one of the programs you have done that. You created a list, stored all the values inside the list, and you return the list. It is not like that. These are very special. Even if I want to return 5 values over a period of time, instead of creating a list, appending each of that value to that particular list and then returning a list, you could just return, yield the value whenever you would like to. When generator function is called, it returns generator object that we saw without even beginning execution of the function. The first time when we had given a call to this particular function here on line number 46, we expected the function control to reach over here, but that did not happen. The first call to the generator function returns a generator object. The generator object can be seen like a function which produces a sequence of results instead of a single object. Normal function, there is only one return statement, or even if there are more than one return statement, once it returns, it doesn't go back to the place from where that has been called. But generators are special. They can return series of values, one after another from the function. When the next method is called for the first time, the function starts executing until it reaches the yield statement. This behavior is like your regular function call. So when you call this next method the first time, then the control goes to the beginning of the function, goes on to execute all the statements till it doesn't come across the yield statement. The yielded value is returned by the next call. The return will continue in the state in which the generator was left. The execution will continue the state in which the generator was left after the last yield. That means, suppose the generator was going to return you 4 values. you gave a first call to the next method. It yielded the first value. So the state is retained in the memory. So the next call, it will go back to the place from where it yielded the value last. It will not start execution from the beginning. That's the beauty of generators. This means that all the local variables still exist. Remember that counter did not get destroyed. Counter value is updated and still returned because they're automatically saved between calls. So it's like a function whose state is retained in the memory between different function calls. State of a function is like what is the all the local variables, what was their value at the time when you gave a call to that function. So that's the state of the function. So the state of the function is retained in the memory. So the next call, it remembers what happened in the last call. Our regular functions, they don't remember what happened in the first call or the previous call. It is destroyed. Here it retains the state of the function in the memory. The fundamental difference to a function, functions always start their execution at the beginning of the function body. So every time you give a call to the function, execution of the function will start at the beginning of the function, regardless where they had left in the previous call. A generator is called like a function. It returns an iterator, that is a generator object. The code for generator will not be executed at this stage. So when we make the first call to the generator function, in that case, the function is not called, rather it returns a generator object. The iterator can be used by calling the next method. The first time the execution starts like a function, that is first line of the code within the body of the iterator, the code is executed until yield statement is reached. So the first call to the next, start execution of the generator function from the first line. Kahan tak? Till the first yield statement is encountered. You return the value. Next call to the next method will not go to the beginning of the function. Rather, it will go back to the place from where it has yielded the value the last time. Yield returns the value of the expression, but Python keeps a track of the position of this yield and the state of the local variables that is stored for the next call. So if I return from line number 12, it will remember. Return means I yield from line number 12. It will remember, oh, that's the line from where I had yielded last, returned last. So next call to the next method will take you to the line number 12 from where it yielded last. It will not start from the beginning. At the next call, the execution continues with the statement following the yield statement, and the variables have the same value as they had in the previous call. That is what I mean by retaining the state of the function. So the state of the function is returned, it retained, it remembers where was the call given during the last call, from where did we return the control during the last call. It remembers that. So that's something very special about the yield statement. Iterator is finished. If the generator body is completely worked through, or if the program flow encounters a return statement without a return value. So when the return statement is encountered, you can think about generator work is over. So this is the return statement. When it is encountered, then it assumes that that generator has exhausted. There is nothing more to be generated now. There is nothing more to be generated. Since Python 3.3, generators can also use return statement. That means before 3.3, you could either have return statement or you could have yield statement. You cannot have both. But in the first example itself, we had return statement at the end. So that was not a behavior that was exhibited earlier. Now that is possible. But generators still need at least one yield statement to be a generator. So how do you convert a function to a generator? A function having yield statement is a generator. A function having an yield statement is generator. Simple like this. Return statement inside generator is equivalent to raise stop iteration. So inside a generator object, wherever you say return, it's like raising this error. Which error? Stop iteration error. So the return statement is like raising the error called as stop iteration. So assume that moment you yield, moment you say return from the generator, it's going to raise stop iteration error. So when you want the generator to stop working, you can just return. Have you understood this? Shantanu, क्या डाउट है? I'm just sharing this example with you. Have you got the file?
Yes, sir.
Just go through the example and we'll continue. Any queries, anybody? Any questions? Let's
No,
go ahead with some more detailed discussion about generator now. Look at this. This function is a regular function. Why? Because it doesn't have a yield statement. It's a regular function. This function is a generator. Why? Because it has an yield statement. So function becomes generator moment it has an yield statement inside it. So let's keep this thing aside for a moment and let's look at this bar function. I'm at line number 35. I'm at line number 35 from where I give a call to this bar function. I'm going to give a call to this function 2 times. But you should remember both the time it's going to return the same value. So X will also have the same value, Y will also have the same value. How is that? Let's see. We give a call to this bar function. 35, line number 35, we are saying bar is equal to open bracket, close bracket. That is a function call. It will not return any object. It may return an object, but it will not create a generator object. It will transfer the control inside the function. It will execute the statements, whatever the statements. Look, counter is printed, counter becomes 2, it's printed, it becomes 3, and we say return counter. So current value of counter is 3. So it return value 3. The value 3 that is returned gets stored into X. So look, X got value 3. We print this value X. Oh, that prints value 3. So here value 3 has been printed. I give a call once again. The function object has been destroyed. So when I give a new call, control will again be transferred to line number 3. Watch it. And right at the beginning of the function. Because the previous state is lost. The free activation record has been destroyed. I again execute all the statements inside the function till the time we do not come across a return. So counter again became 1, then it became 2, then it became 3, and I again return the value. It will still return the value 3. So Y is also having value as 3. So X was also having value 3. Watch it. X was also having value 3. And now Y is also having value 3. It's the same value that has now been returned. That's the behavior of a function. What would happen if it is not a function? If it is not a regular function, it's a generator function. Watch this. Here, functions start to execute. I return yield 1. So it'll return 1. Next yield, next call, it will return this, then this, then this. And note, it's a single function which is returning integer once, a character string later, a floating point value, and a string once again. So a function now, it's a very powerful feature. You have a function that's returning different types of values and at different calls. Normally a function, you may pass as many number of values you can to a function. That's what we normally say when we talk about function. But it can return only a single value and only single time. Now you have a function that can return you a variety of values at different times. See, I gave a call to this foo for the first time. No call, nothing. Watch it. X is a generator object now. It did not even transfer the control to line number 14 inside the function. And if I print what this is, it says, okay, X is a generator. So what is X pointing generator? Now when I call next, that's the time when the control will go inside the function for the first time. Watch it. Control come to foo, execute the statement. So it says fun started to execute, and we are saying yield 1. Watch this very carefully, line number 16. When I say yield 1, now from here control comes back. And it has yielded value 1. So Y will have value 1. Watch it over here. Y is having value 1. And we have printed over here, Y is 1. I give a call for the second time. It will not be yielding 1 now, because it has already yielded this value 1. Control will go to line number 16 and continue further till it does not come across the next yield or return. Watch it. It goes back to line number 16. And then it executes the next statement. So next, yielding the next char, and the char or a string, whatever it is, and it yields the next value. Watch it. Y ka value this time is A. Y ka value this time is A. We print this value. I give the third call. Oh, it went to the place from where it was given call last. It yields the value. It yields now 12.5, 12.4. It comes back to the caller. So Y ka value is 12.4. Check it out. Y ka value is 12.4 now. The first time it was a integer, next time it was a single character, now it's a floating point value. And then again I say next, I again go back, it goes back to the place from where it yielded last. And then it's gonna yield for the last time, saying yield last. So when it yields for the last time, the value of y is last. Value of y is last. Okay, and had I made an attempt to call this once again, that would create real problem. If I had called, suppose if I call it once again, yield is y is last. But if I call it once again, I am not calling. If I call it once again, it will say stop iteration, because there is nothing more to yield. It has already yielded these values. There is nothing more to yield. So any more call to that y function would generate an error. If I say y is equal to next once again, that would again generate an error, stop error. Okay, because there is nothing more to yield. So this function can return 1, 2, 3, and 4 different values at 4 different times. Every time you give a call, it goes back to the place from where the call was yielded last, value was yielded last. First call, it goes over here. Next call, it comes over here. Third, and so on. That's how it works. But I can have more than one generator objects. Let's do it. So I say G1 is equal to foo. That'll create one generator object. G2 is equal to foo. So G1 and G2 are two different generators for the same function. Generator. So I have G1 and G2, two generator objects. If I say next of G1, let's see what happens. Control goes to the beginning. It yields value 1. And then after it has yielded value 1, where am I? Oh, I jumped over. Let's do it again from here. You can iterate over only once. So all these values have already been returned. 1, then A, then 12.4, and then last. All those values have been returned. We are line number 58 now. I give a call for the first time, the second time. So two different generators have got created. Look at this. G1 and G2 are two different generator objects. I say y equal to next of G1. So I pass the first generator object. Remember, we're going to see whether they're in sync or not. First generator object, control went to the beginning. It yielded 1. What's happening? I'm pressing a wrong key, looks like. Here you go. Two different generator object. I give a first call. We go inside. We yield the value. I yield 1. Control is transferred back to that particular line. Y is now having value 1. I print this value. It prints 1. That's great. I can now say next equal to G2. That's the second generator object. G1 was first and G2 is next. It goes back to the beginning. That means one generator object has nothing to do with another generator. These are two different generators, iterators, and they will work independent of each other, nothing else. So both the generator objects were created from the same generator function, but they're independent of each other. Look, the first one yields value 1 again. It's like whether you say step over or not. We have done this, and this was the call that we gave. So the first one again yields a value. Yield 1. Here we go. Y is again printed as 1. Then I say G3 is equal to bus. G3 is equal to bus. Now what is bus? Oh, bus is another function. Here it's also a generator because there is yield counter, yield counter, yield counter. For the first time value of counter is 1, then it is 2, and then it is 3. So bus should return 3 different values. So I get the generator for the bus. I say Y is equal to next of G3. So when I say next, we come over here, it yields the first value. Okay, inside bus, it has yielded the first value. Watch it, it will yield the first value. We print the first value, whatever we have got. I give a second call. It continues from the place from where we had last left, and then yields the second value. It prints the second value. Look at this, y is 2 is what is printed. I give a third call. And it counter now becomes 3, 1, 2, and now 3. It yields 3. It's printed 3. The next call, it will fail. There is nothing more to yield. So stop iteration has now been reached. So if there is nothing more inside the generator to return, it will always generate error calling saying stop iteration. Have you understood this? Point over here to understand was I can create more than one generator object from the same generator function. And they'll work independently. They'll iterate independently over that particular function or over that generator. They'll iterate independently. You don't have to worry. The other question that Viraj had asked, let's see whether that is possible. Suppose I have the generator G1. He was asking, can we do without saying next? Okay, next several times. Let's try. So I say for data in who print data. Let's see what would happen if I do this. Got it? Note कीजिएगा मैंने यहाँ ये नहीं लिखा. I did not say next. So data in foo. What is foo? A foo is a generator function. What is return? It returns a generator object जैसे G1 था. Return generator object. And every time I iterate over, पहली बार 1 दिया, फिर 8 दिया, फिर 12.4 दिया, फिर last दिया. You just keep on giving you one of value after that. Foo की जगह I'll say bars. Because for loop uses this concept of iterator inside. आ गया? Inside bars 1 to 3. How did you get 3 different values? Oh, because it has iterated over 3 times. If I add, so हर बार एक एक value iterate करेगा. पहली बार 1 return किया, sorry, पहली बार 1 yield किया, then 2 yield किया, then 3 yield किया. Inside bars was printed only once. That's it.
सर वो dunder next से भी होता है ना?
पढ़ा?
Using dunder next.
Yeah, that we had seen earlier. ना dunder next से भी होता है.
But sir, do we have to write it repeatedly or only once?
No, you may write it once. It will work only once. Calling the next method or generator object dot dunder next dunder, it's one and the same. So if you call this global function, or you say instead of this G3 dot dunder next dunder, okay, that will also do the same thing magic for you. So here sports dot generate next dunder. So it's for you to decide. Call this magic method next or say next of G3. But this looks very ugly. So we prefer to use this global function next and pass generator. Yeah, you take the generator and say dot dunder next, and that will also do the same thing. But for loop uses this generator only internally. So for loop, when we take to the list, it says we got a list iterator. Are the generators are nothing but iterators. They're enabling you to iterate over that collection or over this set of instructions, one after another. It's going to give you one after another all the values. So I'm sharing the second example as well with you. कोई query है तो पूछिएगा. Any questions, anybody? Everyone understood, yes or no?
Yes, sir.
Quick feedback. I'll show you comparison now. Last time you had written a code for generating Fibonacci series. I'd ask you to return the nth number from the series. But if I want all the numbers from the series to be returned, then what would you have to do? So that's what we'll focus on. Suppose if I ask you to return all the numbers from the Fibonacci series. So let's see. So I want the first n numbers from the Fibonacci series is what we are looking at. First n numbers. The user says 5, I want the first 5 numbers from the Fibonacci series. The user says 10, I want the first 10 numbers from the Fibonacci series. Watch it. I have a function called as Fibonacci function. That's my function, which takes a limit as a parameter. I've done annotation saying it's an integer and it returns a list. Annotations, what we had learned earlier. This is a function doc saying a function for creating a finite series of list of Fibonacci numbers. Okay, that's just a documentation. Nothing more. So I'll comment out that documentation. So I have a list, which is an empty list. I have some variables A, B, C, counter. A has been initialized with value 0, B has been initialized with value 1, C has been initialized with value 0, and the counter has been initialized with value 0. It's like packing unpacking kind of concept. I'm initializing the variables with multiple values at one line. Then I say counter not equal to limit. So limit kya hai? If I ask 5 numbers, I would like to have 5 times I would like to generate the next number. I'll say result dot append C. C is the first number from the series and C ka value kya hai for the first time is 0. So in the list, result list, 0 has been appended. Now A becomes B. That means what gets stored into A is value of B. That is 1 gets stored into A. B becomes C. So B becomes 0. And C becomes A plus B. So 0 plus 1 is 1. Counter becomes 2. And we go back. Is 2 less than equal to limit? Suppose limit is 5. 2 less than equal to 5. Yes. We append C. C is 1. So 1 gets appended. A equal to B. B is 0. So A again becomes B is Bilal C 0 tha. Okay, so A becomes 0 and 0, 1, 1. Okay, and then B becomes C and C is Bilal 0. Okay, let's do the dry run for this. That will be easier. Okay, let's do the dry run. And I hope you haven't forgot what the dry run is all about. Let's do the dry run. Here we have variables like A, B, C, and counter and limit. Value of, and let's take the color to be yellow, suppose. A value is A ka value for the first time is 0. Initial values will come here. A is 0. B for the first time is 1. C for the first time is 0. Counter is also A is 0, B is 1, C is 0 and counter is also 0. Counter is also 0 and assume करते हैं limit जो है वो समझो 4 है. I want या 5 है. 5 numbers from the series is what I want. These are the initial values. Okay, these are initial values. So we go here. Counter not equal to limit, 0 not equal to 5, yes. Result equal to 0 plus result is equal to result dot append C. C का फिलहाल वैल्यू क्या है 0. तो आपका रिजल्ट कहीं यहाँ आना चाहिए. रिजल्ट में आपने अपेंड किया 0 for the first time. Then we say A equal to B. So B का वैल्यू 1 है, so B stored into A1. A now becomes 1. Then we say B equal to C. C is 0, so B becomes 0. Then we say C equal to A plus B. 0 plus 1 now becomes 1. Counter becomes 1. Counter becomes 1. Limit is still 5. Limit is still 5. That's what has happened for the first time. We go back. Counter not equal to limit. 1 not equal to 5. Yes. Result dot append C. C में value क्या है फिलहाल 1. So 0 plus 1 that now becomes 1. So we append 1 to the result. ये आ गया 0, 1 हो गया. Then we say A equal to B. So A में आ गया B का value 0 है. So here we get value 0. We get value 0. After that we are saying B equal to C. So C का value 1 है. तो B में आ गया 1. Then we say C equal to A plus B. That's again 1. Counter becomes 1 plus 1. That is 2. Limit is still 5. That's unchanged. Limit is still 5. That's unchanged. That no change over here. Okay, so that is what has happened next. Again, we counter not equal to limit. 2 not equal to 5. Yes. Result dot append C. तो C में value क्या है फिलहाल? C में value 1 है. Here look at this. C में value 1 है. तो 1 will get appended to this particular result. So it now becomes 0, 1, 1. That has been appended. A equal to B. B का value 1 है. तो A becomes 1. B equal to C. C का value 1 है. तो B becomes 1. B becomes 1. C is equal to A plus B. That becomes 2. Counter now becomes 3. Limit is still 5. So that's the state now. Again, we want counter not equal to limit. 3 not equal to 5. Yes. It is equal to result dot append C. Result में क्या है ये है dot append C. C में value क्या है 2 है. So 2 will now get appended to that result. So it becomes 0, 1, 1, 2. And then we say A equal to B. B का वैल्यू 1 है तो A becomes 1. B equal to C का वैल्यू 2 है तो B becomes 2. And C is equal to A plus B, that becomes 3. And counter now becomes 4. Counter now becomes 4. Counter now becomes 4. And limit is still 5. Limit is still 5. Limit is still 5. Again, counter not equal to limit. 5, 4 not equal to 5. Yes. Result dot append. यानी 2 के आगे आप append करोगे अभी C का वैल्यू 3 है. So 3 will get appended. So what we'll have is 0, 1, 1, 2, 3. So that is what it is. A equal to B. So B में तो A में दोबारा B आ गया 2. B equal to C. C में 3 है तो B में 3 आ गया. C is equal to A plus B. 2 plus क्या हुआ? A equal to B. That becomes 2. B equal to C. C में वैल्यू 3 है. So that becomes 3. And C is equal to A plus B. That becomes 5. And counter is equal to counter plus 1. That becomes 5. And limit is also 5. Okay, here we go. Counter not equal to limit, 5 not equal to 5, condition is false. तो false है तो लूप में से बाहर आओगे. से रिटर्न रिजल्ट में क्या है? 0, 1, 1, 2, 3. इस तरीके से पूरी लिस्ट रिटर्न करोगे. पूरी लिस्ट रिटर्न करोगे. अंडरस्टैंड माय वर्ड. So once this list is being returned, you come over here and then we cycle through all the elements inside the list and we print every element from that particular list. So let me just comment out rest of the code and run this particular program, and it has printed 0, 1, 1, 2, 3 because limit was 5. It was 0, 1, 1, 2, 3. But the point was, this was costly because when you came over here, you created a list. You went on appending with the result to the list, and at the end you return the entire list. Correct? So if there was, instead of 5, the limit was 500, you'll have in the memory 500 values being stored at one particular point of time, and the entire list of 500 values is going to be returned. So it's going to consume a lot of memory. Okay, watch this. Let's go to the visualizer once again. If suppose this is the function that we have, and let's get rid of the comments. This is the function that we have. Let's also get rid of this dry run that we have done. I hope you remember the dry run. Huh? How to do the dry run? We'll see. Let's start with visualizing. See what's going to happen. Huh? Watch it very carefully. Function is created. Line number 18, we give a call to this function Fibonacci limit function with the limit as a parameter. Here we go. We come to this function. When we are inside that function over here, the result is a variable that will get created. Look, limit has been received. Now there is a list called as empty list called as result that gets created. What I'll do is, just to make it readable, I'll eliminate few statements from here so the size of the function is small enough. So we can visualize it at one time. I say visualize, so entire code is visible now. Indentation not proper. Again, I visualize. Here we go. A function has been created. Line number 14, we give a call to the function. Control comes inside the function. Oh, there is no variable for its limit. I say 5. Here we give a call at line number 14, control goes into the function. We have this function parameter called as limit whose value is 5. Empty list has been created. Look at this. It's an empty list that has got created. We have these variables A, B, C, D, counter not equal limit, whatever written, result dot append. With the list, value 0 has been appended. Then we do all those operations. Then the next value is appended. Can you see 0, 1? Then the next value is appended 0, 1, 1. And the next value is appended. That is 2. The next value will get appended. That is 3. And then it will create the next value, but will not append. So your next value of count C is 5. That could have been appended, but counter is equal to limit. Counter ka value 4 tha, limit ka value 5 hai. Okay, now counter will become 5. Watch. Counter becomes 5. 5 not equal to 5, condition is false. So it's going to return this entire list for you. The return result, the entire list will be returned. Don't watch it. The return statement is pointing to this list. So entire list will now be returned. And that list that has been returned has now been received here. Fibo list is now referring to this list. So you have limit there was no such variable. So it is generating an error. I could just say over here, first 5 elements are so on, because we have made the changes. First 5 elements are so and so. And we could print the Fibonacci series, whatever the number is. So if I visualize it and I say this is a statement I would like to run directly. The first 5 numbers are, and I want to print this next statement. It'll print 0, 1, 1, 2, 3. All these numbers have got printed. Point 1, the list was created and the entire list was being returned. So it will occupy, if there was, if I give you a problem now, if I tell you print infinite, return infinite number of values from the Fibonacci series, how will you do that? Because you need to know where to stop so that you'll have a list and you can return. That is something that we could do through generators. So as long as the user wants, we can just keep on generating the next value, the next value, the next value, the next value, and keep on returning it to the user, not bothering about when to stop. Okay, because it's an infinite iterator that we could create, infinite iterator. Here it will iterate over, it is returning only n number of values. And if I tell you write a function Fibonacci series, which will return infinite number of values, so आप बोलोगे infinite loop लिखोगे, you'll never come out of that function. You'll just keep on generating those values. It will not return the value. It may probably print, but it may not return the value. So मुझे program में वो value चाहिए at different point of time. Think about generators. Watch it. The same thing I could achieve by creating a generator. This was a regular function. Instead of what we did earlier, I could write the same operation. These 3 lines of code, I could do it in this way as well. So there was another way to do this, better than the previous version. So you could check this version later. If I'm now going to create a function called as infinite Fibonacci series, and I'm going to say return while true, infinite true, it's always true. And I'm going to say A equal to B and B equal to A plus B. That's it. And I'm always going to yield A. For the first time, A value is 0. Second time, A value is 1. Third time also, A value is 1. So if I take this particular function, Fibonacci infinite, if that's the function that is stored in the memory, and now if I call that particular function, watch it, here, I call this function, watch it carefully, yeah? I'll debug this code for you. I call this function for the first time, nothing happens, generator object is created. I say next Fibonacci generator, I get the value. I print the value, 0 again. Next, I get 1. Next, I get another value. Not just that, अगर मैं ये next और print करते रहूं multiple times, let me stop. अगर मैं next और previous करते रहूं multiple times, 8, 13, 21, 34, 55. Look at the values. 233, 337, 600. अरे ये जिंदगी भर return करते रहेगा. When you want, you just keep on returning the values. Can you see this? 832040 plus the previous one, plus the previous one. It will just keep, it will never fail. Neither it's going to infinite loop. It is a function. As long as you say next, it will just keep on returning you the next value. And what is it doing? It is just adding your A ka value is 0, B ka value is 1. It yields 0 for the first time. A becomes B and B becomes A plus B. That's C is equal to A plus B, what we had written. And you just keep on repeating this code. And every time you're going to yield, it will stop over here. So it remembers what was the value the last time. So next time when it goes back, it gets the previous value of A and B. And so we have an infinite generator that we have created. When you want the next Fibonacci number, you just say next and the generator. You'll get the next Fibonacci number, what you would like to have. Not just that, you could now write a loop. And if you have this Fibo generator that is created over here for the first time, suppose. If I have this Fibo generator being created over here for the first time, from the generator, whatever number of values you want, you can fetch. So I'll say limit is 5 for value in the range limit, that is 0, 1, 2, 3, 4, 5, 0, 1, 2, 3, 4. Give 5 numbers. जितने चाहिए तब आ गया. Next 5 चाहिए, next 5, next 5 चाहिए, next 5. तो अगले 5, अगले 5, अगले 5. That's the powerful behavior of. Look at that. Every time the next 5, next 5. I should change the message, not the first 5, but the next 5. You do it for your lifetime. Till the time you do not run out of memory, you just keep on doing it. And at any point of time, it's not calculating, it's not storing the results. It's calculating the results on the fly and returning you. Watch it. I can write the code in another way. I could say Fibonacci generator, again a fresh new generator will get created. I say choice is equal to y. Yes. Upper jab tak y hai, tab tak continue karenge. Means if I'm going to execute this particular code, as long as you want, I'll keep on generating. Para value 0 आ गया. Press Y or yes to confirm or other key to stop. I say Y. 1 आ गया. Y 1 आ गया. 2 आ गया. 3 आ गया. 5 आ गया. 13, 21, 34. So we have a generator. We keep on generating all the values. देखो. I said YES. आ गया. The day when I say no, it will stop. We have generated those values for you. I can create a program in a different way as well. I say import time, Fibo generator is infinite, I value in Fibo generator, and I'm going to sleep. So this will just keep on generating values over a period of time. Watch it. 0, 1, and we are suspending the operation by 2 seconds. So infinite generator there. And it's not, the values are not being printed inside the function, huh? They're returned every time. So every time this for loop is printing the value. Okay. And the only way to stop is stop. Oh, how do I stop? I go here and I say Control C. That's the way to stop. Have you all understood the power of generators? I'll be sharing this code as well with you. There's more to generators actually.
सर पर लोकल वेरिएबल का भी तो वैल्यू कहीं तो स्टोर होता होगा ना.
हाँ, ग्लोबल वेरिएबल का भी वैल्यू, ग्लोबल का वैल्यू कहीं और भी चेंज हो सकता है. फंक्शन
ग्लोबल नहीं सर, लोकल लोकल.
हाँ.
जो वो फंक्शन चालू है,
हाँ.
उसके अंदर के वेरिएबल.
हाँ.
वो भी तो कंटिन्यूअसली, मतलब तब तक वो फ्री नहीं होएगा.
Return to the caller, or only once inside the function, you will only print inside the function. Suppose your program required the values, the numbers from the Fibonacci series different times. Okay, it is not inside the function. Outside the function, if I require those values being calculated, tell me what will you do with the local variables? While you are inside the function, you could do whatever you would like to. I give a call, I come out of the function, and the value that the function is returned, I'm utilizing that value. I'm the consumer. I'm consuming the different values that the generator is giving me. With the local variables that we could have created, the list that we had created, we had to consume. Suppose if I had asked you to print all the numbers from the Fibonacci series, infinite, you'll have to write that print statement inside that function, isn't it? Or can you write it outside?
No, inside.
I tell you, get me the square of all the numbers from the Fibonacci series. So in that case, once you return the first number, you cannot go on to get the second number. Here it will return you the first number, then you do whatever you would like to do with that particular value that has been returned. So the difference is, when you call a function, once you return from the function frame is destroyed. With this yield statement, when you call that function, so-called generator object, you will get the value the very first time where it has yielded. Next call will continue from the place where it left last and continue the rest of the instructions. That's impossible to believe as a C programmer or a C++ programmer. This is just not possible in other languages. That's what makes Python stand out from other languages, such features. सोचिएगा आप global variable से भी करोगे, then also what happens? Next time when you give a call to that function, even if there is a global variable, start from the first line again. That means probably you'll get the same value all again. You will not get the previous value.
Yes.
Yes or no? Otherwise, all the variables you'll have to declare global. But problem is then some other function may also change the value of that variable.
Yes.
Okay. Here, now the lifetime and scope. So the visibility of the function is limited to that function, but lifetime is throughout the program. So that's something very special. So lifetime is like global variable throughout the life of that application, but visibility is only inside that function. So only when you come inside the function, you can see that variable. The moment you come out of the function, the variable is not seen. So earlier we had local variables whose visibility and lifetime both were restricted to the scope of the function. Now we have a scenario where I have a function whose visibility is like local variable, but whose lifetime is like a global variable. And that's possible if I define that function as a generator. So we can get this kind of behavior. So I'm sharing this code also with you. Just have a look at it. Any queries if you have, please let me know. I got this function.
Yes, sir.
Let's do something very simple. If I tell you, get me square of the numbers, I could still write a generator for that, getting square of the numbers. But if I really want to have an infinite one, I'll have to write a generator. So every time you give a call, you should give me the square of the next number, the next number, the next number, the next number, the next number. Just for sake of practice, let me show you a generator. And believe me, this is not all about a generator. You may find this is very different. That's true, but this is more like introduction to generators. I would not like to bother you with all the details what generators can do right now, because we're going to come back to generators again when we design classes, because that will also enable us to create a generator. So I'll be talking in this is introduction to generator, but the details of generators will decorators and generators will come back again once we learn object-oriented programming in Python. There I'll talk something more advanced about generators. Here we go. Let's have a look at this function. I have generate squares. When I pass a limit, I say for I in the range 1 to limit plus 1, yield I raised to 2. That means that the first time agar I ka value 1 hai, so 1 ka square, then 2 ka square, then 3 ka square, and so on. But every time I'm going to yield the value. So if I have this particular function reading the memory, and I say I'm here at line number 21, and I say print next square, watch it, what happens. I got 1. Next square, I got 4. Next square, I got 9. Next square, I got 16. Again, if I go here and I say next square, suppose I'm selecting this statement, 25. Okay, and then it stopped. Why did it stop? Because you had passed limit as 5. Since you had passed limit as 5, this loop will get over and you're going to say return. The moment you say return, it has stopped iteration. That means there is nothing more I can generate. Because this loop got terminated, yield statement is no longer being executed. Now what we are doing is you are returning. This return statement inside generator was not available till Python 3.3, and we are in Python 3.11 now. So this return and yield together, such kind of combination is not available earlier. Earlier we could either write a function with a return statement, or we could write a function with a yield statement. Today both the things are possible. Think about return as if we are terminating that generator. That means the generator will no longer generate any values. It is generator being exhausted. It will raise a stop iteration error. Because it has finished executing the things. So that was generator which is generating certain number of elements. Let's give a call to the generator square once again with limit as 5 and we'll run this code. So 5 है तो same thing. Last time also 5, again we'll yield 5 statements. Here we go. We got 5 values, 1, 4, 9, 15, 16, 25. How about infinite generator? Watch it. I say while true, counter value is incremented and we yield the return, yield that counter value 1 ka square, then 2 ka square, then 3 ka square. Okay, and every time I'm going to yield. So it will not continue the loop till the time the next loop iteration will happen during the next call. Okay, next till the time you don't call the magical method next, the next call will not be given. So watch it. I'm here. I got the first square, that is 1. And then, oh, I'll just keep on calling this line number 34. Watch it. 4, 9, 16. Lifelong you keep on doing this, you'll just keep on generating the number as long as you say next. And jab chahe rukna hai, ruk jao. Your generator is going to give the next value. It's never going to get exhausted. And it's not going to store all these values like what we did in the last example. These are generated on fly. That means every time it will calculate and return the next value. They are not stored. What it stores is only the state of the function. That means state of the variables, local variables, which are part of the function. So that state is being maintained. It will not store the result or something like that, what we had done last time. Okay, that's the beauty of generators. It will generate value on fly. It does not require a list or some kind of container which will hold the results and then return all the results at one go. Nothing of that sort. You understood this? Any questions, anybody? So the return statement that we write inside generator is as good as saying raise, stop, iteration. Now just to prove that point, let me do that. I have a function called a generator, and this generator is going to return yield only a single value. If you ever think about writing a generator which is going to yield a single value, don't go ahead to generator, use a function, regular function. Use a regular function and say return 99. That was good enough, since you are planning to return only a single value. If you plan to return over a period of time more than one values, only then think about generators. So I say def gen1 yield 99. Oh, it is just like saying return 99. I have the generator. I create the generator object. I get yield, I get the next value, that is 99. And if I make the second call, it's going to fail. Stop iteration. Because there is nothing more to be yielded or returned from that function. It could return only a single value, that is 99. It has exhausted, nothing more to be returned. So it raises an error automatically called as stop iteration. But why automatic? Can we not raise an error? We can do that. So I have another function gen2. It also yields 99, but says raise stop iteration -11. So that's a error code it will return. So that's another function called as gen2. That's another function, another generator function. Let's do that now. I create the generator function, our generator object. I give a call over here for the first time. I got 99. And during the second call, what will happen is it says runtime error, raised stop iteration, and stop iteration value -1. Look at that, -1 of the return value. But you don't want to write the raise. You are not aware about exception handling as of now. So you don't plan to write this raise and error or something like that. You can just say return. This will also do the same thing. So return statement and raise will give you the same behavior. Watch it. Here we go. I have this third generator. It will generate the value correctly the first time we call. Let me do it again. I have this third generator. It will return the value correctly when we give this first call. Again 88. And when I give the next call, it says stop iteration -22. Okay, just to help you understand, let's run this code directly. Oh, one thing at a time. I'll comment out these two codes. Let's work with only one generator 1. Okay, so it has yielded value 99 and then it has generated an error. Why? Because next was this. I comment out this statement. I do it the second way, wherein I am raising an error. So the behavior will still be the same. It gives you the first value, that is 99. And then because of the stop iteration, we have said raise stop iteration at line number 18, it has stopped. Line number 18 has stopped. Same behavior. Okay. Let's see the third behavior, where I don't say raise stop iteration. I'm not raising that exception. Rather, I'm saying return to minus 22. Oh, I still get the same behavior. Look at it. I got value 88 and then it has crashed. Line number 36. That is a statement which has crashed that particular program. Why? Because you have returned a value and the second call, there is nothing more to return. So it has exhausted. So return and stop iteration, as Jenkins says, look at it, stop minus 22. Here we have got, and here we have got stop minus 11. So minus 11 was here and minus 22 was here. So as far as generator function goes, the raise statement, raise stop iteration and return is exactly the same. Use whatever you are comfortable with. I prefer using raise because it is very explicit. Oh, if something goes wrong, or if I'm exhausted, there is nothing more left out, then this is what I'll return. Have you all understood this? Any query, anybody? Quick feedback. Now let's look at the last example we'll take. Although there are a few more examples where we can talk about applications, but let me just take one last example. Yield is a construct which is not just used to return a value, but it can also be used like every time we give a call to a function. Suppose I wanted to find factorial of a number. The first call to that function factorial, I can pass value 4 whose factorial I want. The next call to the function factorial, I could pass say 10. I could get factorial of 10. That means while you give a call to a function, you have a chance that every time I call a function, I can pass different arguments, correct? So likewise, we can do even for generator functions. Every time I say next, I can pass a different value, but where will that value go? Let's try and explore that. Okay, this is slightly more advanced. Pay attention. I have get values. The first call to these get values will yield you 0. The next call will yield value of square, value ka square. But what's the value of this variable val? Okay, let's understand this now. If this function is read in the memory, and I give a call from line number 21, a generator object will get created. Line number 30, I give a call to this next function. Watch it very carefully from here. Or let us go ahead debugging this code from here so that you understand it better. I'm at line number 30. I say result next gen. It will take the control inside the function for the first time. Here we go. It'll yield value 0. That means it will return. Yield is like return to some extent. It returns the value 0. But this time, for the first time, I'm saying equal to something. What is that behavior? Let's try and understand. But yield 0 will transfer value 0 to the caller. Here we come. We have come to the caller. This result will get value 0 and we print value 0. Got it? Till here, the behavior is same. But next time when I'm giving a call, I'm saying generator.send. I'm not saying next. I'm saying send. So I plan to send value 2 to the generator where it yielded last. That value 2 I'm going to send will now get assigned to this particular variable over here. So, till now, we are using yield as a statement which could only return a value to your caller. Now we are looking at yield, which will also act as a way for the caller to pass some data to that particular generator function. So this particular call, line number 32, when I say send instead of next, I'm saying send. I'm going to send this value to the place from where we yielded last. That means this statement was the last yield statement that has got executed. Sorry, this statement is the last yield statement that has got executed. There I'll substitute value 2, which will now get assigned to variable val. So I'm going to get square root of 2. Watch it. I say send. We have come back to the same statement, but need to check what's the variable value of this variable val. Note kijega, in variable val, we have value 2 now. So whatever we have sent, that has now got assigned to the variable which receives the value that has been sent to that next call to that yield. Now watch it. I say yield value ka square. Value is 2. 2 ka square is 4. So that value 4 will now be returned. Here we go. Value 4 has been returned. So we say result is 4. Value 2, result 4. I say gen dot send 3. Now when I say send 3, or I could have said 13 also. It's our choice. Kya bhejna hai. I say gen dot send 13. So moment I send 13, value 13 will be sent and assigned to this particular variable val. Okay, let's stop this code and do it again. We are here, 13. Okay, I had not saved the file, so I just debug it from here. So 13 will now be sent. Here we go. And check value of variable val. Earlier value was 2. Now let's check what's the value of this variable val. It's 13. Whatever value is sent. Now you'll get 13 ka square. That has now been yielded. We'll return to the caller. We'll get 13 plus square. So we got square of 13, that is 2197. And then I say gen dot send 4. Now 4 will be sent and assigned to this particular variable val. Oh, that's cube. Now it will be assigned to this variable val where it has returned. So val now becomes 4. So 4 raised to 4 is what we'll have. So 4 raised to 4, that's the value it will yield. That's the value it will yield. We print the result. Here we go. We print the result. And we have printed result as 256. We have printed result as 256. So send will act as a behavior. We can send the value to the generator for generator to process. So for the next operation, whatever is the value that you have sent, that will be used. So yield is not just used to return a value. It can also act as a way the caller communicates with the generator and transfers the value to the generator, saying the generator use this data and now do some operation manipulation, get me the result of that. So every statement, every place where you have said yield is powerful because it will not just return the control and the value to the caller, it will also get the value that the caller has sent by calling a method called as send. Likewise, I also have a function called as square. It's an infinite function. It will always print 1, yield the value, but whatever value here I'm not going to yield any value. So it's going to yield nothing. So value will get assigned, whatever value you send. You're going to print and whatever value you send, uska square le gaya. So let's do that. You're just going to print the square of the number that you sent. Okay, we always print 1, 2, and then not 1, 2. Yeah, 1, 2, and yield the value. Let's see. I get the square. So we are at this line number 39. We got the generator. I say next. I print the result. I got none. Why none? Because you said yield. You have not written any value. So yield without a value will return you none. I send 10. So whatever value I send, that will get assigned to this variable val. It will print 2 and then 10 ka square will be yielded. Watch it. It prints 2 and yields 10 ka square. Then I say next. But next, when I say next, it's going to print 1 and yield nothing. Yield nothing. I say send 10.5. Go. 10.5 will now be assigned to this variable val. And second time, 10.5 ka square is what you will get. Look at this 10.5 square is 11.25. And I say next. Oh, that's again do the same thing. Print 1 and yield nothing. Print 1, yield nothing. None. I say send A. Oh, when I send A, you will have print. Oh, let's see what happens when I send A. Okay. It says can't multiply with string. That's very correct. I send A and I'm going to multiply A with A. So it will generate an error. Okay. Cannot multiply strings. It says can't multiply non-int value string because you're passing A. A is a string. We cannot multiply. If I said ORD of A, then A ka value is 65. Code point is 65. So you get square of 65. Not square of 65. It's like, yeah, square of 65. 65 into 65 is what we have. Have you understood this special behavior of yield? What more it does? It will not just act as a way for the generator to return a value to the caller. Caller can also send a value to the generator every time. So I can say, okay, next time I want to find some value, I'm going to send some number and then it will manipulate the number and give you some result. You can do anything. The best part is the generator is not created and destroyed every time. It is there in the memory. So it is more effective than your function whose frames are to be loaded and destroyed. Its state is preserved in the memory. So these generators are what do you say, more effective way of writing a function which is persistent in the memory, whose state is preserved. We understood. Ruturaj, what's the doubt?
No, I have understood.
Pardon?
Understood.
Okay. So with that note, I have shared all the examples with you. I'm just going to share one more example for you just to have a look at it, just to understand how the value is being sent. I want you to explore that function. How does it send work is what that function demonstrates, just the behavior. And later we'll again come back to generators when we talk, when we learn some more details, we can talk about some advanced feature of generators again. What I'll do is I'll share 2-3 examples with you, and I'll leave it up to you to explore those examples. Just explore some additional examples that I'm sending for all of you. Explore those additional examples that I've sent and be ready for the next class. Ask whatever questions that you have during the next session. Okay, but with that note, we'll stop over here as far as generator goes. So we have covered one very important topic called as generators today. Tomorrow when we meet, we again talk about some additional advanced concept called as coroutines and subroutines is what we look at. And then we will talk about generator expressions. That will conclude our discussion on generators. Okay, and coroutines, subroutines, that's again an advanced concept that we look at. So coroutines, decorators, closures, these are some very advanced features we are discussing right now. You'll very rarely find description or discussion on these in any regular Python textbooks, unless we look at references. So explore them. If you don't understand the purpose, do ask me questions. Tomorrow again, we talk about a kind of generators, and we'll continue this discussion on advanced topic for the next 2-3 sessions. So with that note, we stop here today. See you tomorrow. Take care. Bye-bye. Any questions, please ask.